The topic is finding the differential of a function of two variables. So let's do the first example. Find the differential of f of xy equal x cubed times cosine of 3y. So this means the differential at any point xy, and this is the definition. It's fx of dx, fx times dx plus fy times dy. So first we need to find fx. What we mean with fx, just partial derivative with respect to x at any point xy. In other words, we're looking for fx of xy. Now this is going to be partial with respect to x of x cubed cosine of 3y. Now cosine of 3y is a constant. We can take that outside. So it's cosine of 3y partial with respect to x of x cubed. Now this is going to be equal to partial with respect to x of x cubed is 3x squared. So 3x squared cosine of 3y. Alright, now we need to find partial with respect to y of f of xy. So again, partial with respect to y, you get partial with respect to y of x cubed cosine of 3y. Now x cubed is a constant, I can take it outside, so it's x cubed partial with respect to y of cosine of 3y. Now we need the definition of derivative of cosine of u is minus u prime sine of u. So in other words, this will be minus u prime, in our case is partial with respect to y of u is the inside, of 3y sine of u. But don't forget the x cube, this x cube. Where do I write it? I just write it here for now. Alright, now this is going to be equal. I'm just going to move it there. So, and the partial, let me do this so it doesn't confuse you. Partial with respect to y of 3y is 3. So it's minus 3x cubed sine of 3y. So this is partial with respect to y of xy. Now the rest is just plug in. Now we know that df or dz, df is equal fx of xy dx plus fy of xy dy. So df is equal, just plug it in. So plug this in. So it's 3x squared cosine of 3y. All of this dx plus, which is partial with respect to y, all that, plus minus 3x cubed sine of 3y dy. Now for question B, find the differential of f of xy at 2 pi over 6, means plug 2 for x, plug pi over 6 for y. So let's do that. df is equal, whatever I see x, I plug 2. So this will be 3, 2 squared, cosine of 3, plug pi over 6 into y, pi over 6. All of this dx, plus, same thing, negative 3, 2 cubed, sine of 3 times pi over 6 dy. Now df is equal, 4 times 3 is 12, 12 cosine of 3 divided pi over 2, cosine of pi over 2, just want to make sure I didn't make any mistake. Cosine, no. Yes. So cosine, let me write it. Cosine of pi over 2, which is 0, Was not expecting that. Dx, and this is minus 8 times 3 is 24 sine of pi over 2 dy. Now cosine of pi over 2 is 0. 0 times dx is 0. So that would be minus, sine pi over 2 is 1, so negative 24 dy. Alright, let's do the next example. Find the differential of f of xy equal 5x e to the negative y. Same thing, we need to find partial derivative with respect to x, which is partial of 5x e negative y. Now e to the negative y is a constant. I can take it outside. Partial with respect to x of 5x, which is 5. So it's 5 e negative y. Now same thing, partial with respect to y of xy is equal partial with respect to y of 5x e negative y. Now 5x is a constant, take it outside, of e negative y. Now I have to use this formula. Let me rewrite it here. Derivative of e to the u is u prime eu. What does this mean? That this becomes 5x. The u prime means partial with respect of y of negative y times e to the u. Now this is going to be equal 5x. This is going to be just negative 1, so it will be minus 5x e negative y. Now therefore df will be equal fx is right here, so 5e negative y dx plus negative 5x e negative y dy. Right? Now for next question, find the differential at 1, 0. So we need to plug 1 for x and 0 for y. So the df will be equal 5e, y is 0, so it's negative 0 dx plus minus 5, x is 1, e to the negative 0, and then dy. Now our df will be 5 times 1 is 5, so it's 5 dx minus 5 dy. And that would be the answer. And that's it for this example.